17. Now, see, the problem with this is we don't get the suspense of me staring at the chart before we find out who it is. We have Lucas. Okay, Lucas, I can try to set you up with the question if it helps. Do you know what factoring is? Oh, all right, I'll try to set you up then. Okay, the last unit, we did distribution and stuff, right? What's distribution or foiling? Okay, so you multiply out the things. So you multiply out the things and you get an answer. Factoring is the reverse of that. I'm going to give you the answer and you have to figure out what was multiplied to get that. Uh-oh. What happened? Oh, a number line. Oh, I'm definitely putting this up, Sully. Thank you. Oh, this is old. It's been sitting in my drawer since 25 years?
Well, at least over 13 since
We can make fun of it, but it's going to go up, and it'll be appreciated.
I got some other old school stuff too.
I was made fun of for putting up a multiplication table up on the wall. But then we surveyed people who were walking by in the hall. And so far, 50% of the people knew what 9 times 8 was. So I'm thinking this is a good idea and you guys need this badly. So when you're bored, just stare at it, soak it in, memorize it. You'll get it down. It'll help you out quite a bit in your next 2 classes. Yeah, I'm going to pretend like I remember what we were talking about factoring. Did you answer it? I don't remember. Yeah, so I'm going to give you the answer and you're going to figure out what was multiplied to get the answer. So this unit is the exact inverse of last unit. You're going to have to figure out what was multiplied from the answer you're given. Now we're going to take it in baby steps though. It's not like I'm just going to give you a direct problem right away and be like, figure it out. So if you look at page 1, I know there's a, that's not a times, what is that? Oh, prime numbers. Nope. I'm not doing that with you. Have you done factor trees in the past? I believe we have this year, to be honest. Yeah. What did we do that for again? Grace come a factor, maybe? Mikey, we need somebody that's going to come up here and do a factor tree for us. 18? That's Heidi. And it's perfect because you won't need to see because you'll be right next to the board.
Okay.
Come on up. Okay, we're going to do a different one because all the answers are given to you at the bottom of that page. So should we really test your memory?
No.
We did them earlier this year. Okay, let's pick a number. Mikey, what's a number we should do? A bigger number.
4.
I'm worried what your idea of a smaller number is. So we were supposed to pick a bigger number.
Oh, bigger number? Oh, 48.
Sure, perfect. 48, that's got a lot of factors. That's a good one. If this was a prime number, this would be worthless. That's a good one. Okay, underneath 48, you're going to make like a little branch, which is why they call it a factor tree. And then you're going to pick any 2 numbers that multiply to 48. 2 and 2 would make 4.
Oh.
So 2 times 24.
Oh.
So the 2 numbers you pick have to make the number above it.
Oh, okay.
And this is definitely where the multiplication thing will come in handy if you need it. Okay, so now 2 is prime because nothing multiplies into 2. So you're going to circle it.
2.
Yep. 24 can be broken down further. Pick any 2 numbers that multiply to 24.
12 and 2.
Sure. Now, I will tell you if you just keep picking 2, your tree is going to be super long, but it works. So you can keep doing it. So circle the 2. Yep, now you got the idea. Okay, 3 is prime as well. Correct. 4. Do you want me to scroll down a little bit?
Yeah.
Okay. Circle both of them. Okay, so now this is the prime factorization. And a factor tree is kind of how you can do that with any number. It doesn't matter what numbers you pick. So like you started with 2 and 24, which works. If you would have started with 6 and 8, you would have ended up with the same circled numbers at the end. Now looking through that, it looks like we have 4 2s. Am I seeing that right?
Yeah.
Okay, so then your answer that you would write is 2 to the 4th power times 3. Now, if you don't want to write it to the 4th power, you don't have to. You could write 2, 2, 2, 2, 3. Like you could just list them all separate. Now, wait, let me move this. Do you want somebody else to do the other half, or do you want to keep going?
I can keep going.
Okay, you kind of like this, huh?
Yeah.
We need a number. Let's pick 36, and then we'll do it on this side. Good start. That's
Do I need for both of them now?
correct. Correct. So you basically keep breaking down a number until you get it to be the little prime numbers. And what you're going to find is if you pick numbers close together, like she did, 6 and 6, your tree is much shorter. But it doesn't actually matter. Okay, so we've got 2 squared, 3 squared. You can just put it underneath, whatever. Oh, okay. That's fine too.
Times 2 squared?
Correct. Now, our goal is to figure out what they have in common. So 48 and 36, we're trying to find the greatest common factor, is what it's going to be called. This is one method if you don't know the numbers in your head, which I'm going to guess you don't know a lot of numbers in your head, so that's not a bad thing. So the one on the left has 4 2s. The one on the right has 2 2s. So in common would be how many 2s? Nobody? How many do they share in common?
2.
2. So down near the bottom, we're going to write 2 squared. You're going to write down what they have in common. And then let's see, we've got a 3 over here and 2 3s over there. So how many 3s do they have in common? 1. So then times 3. And then 2 squared times 3, what does that give us? 12. So equals 12, circle 12, and then that's going to be our greatest common factor. So GCF, underneath 12, but GCF. Now, if you were given 48 and 36 from the start, and you knew 12 was the biggest number that goes into both of them, you could have answered that right away. So the greatest common factor is going to be us trying to figure out what's the biggest number that goes into everything. 48 and 36, 12 is the biggest number that goes into both. If you don't know that in your head, these trees is the way you're going to figure that out. Does that sort of make sense? Probably a little bit yes, a little bit no. We should definitely try another one together. I believe they're directly on the next page. Excellent job, thank you. You need a charger, it sounds like? It was? Oh, that sounded like low battery.
Sorry.
Okay, so we have 30 and 56. Should we do that directly together, or do you guys feel like you could do it on your own? Do it together? Own. Try to make a factor tree for both numbers. I'll zoom in here so I can. What'd you do for the first 15 minutes?
Wash.
Carter, you got to work on note-taking abilities. You need to try to figure out which numbers they have in common. That's it. That's it. Mm-hmm. That's what I got as well. So if you did this correct, it seems wrong because the numbers are bigger and you feel like there should be something that goes into both of them. Excuse me. They only have one number in common. That's what I circled in red. And once I was writing this on the board, I realized it might be easier for you guys just to directly look at them and see what they have in common rather than writing the answer like 2 to the 4th or something. You kind of have your choice on how you want to do that. But as soon as I started circling numbers, I saw the only circled numbers in common was a single 2. So 2 is going to be the greatest common factor. Is that what you guys got? Do you want me to explain anything up there, like help you walk through it? Okay. Then, before we do more numbers together, slide to the right, and we have this. Is that like way worse? How come? It's got letters? Letters are not scary. They just make words. Not in this class, but they make words in other classes. We're still trying to figure out what they have in common. Okay? If you are given monomial expressions like this, you're still just trying to look what they have in common. So we've already figured out the common number. Correct? So what's the common number between 30 and 56? The biggest one that goes into both? Just 2. Okay, now I'm going to look at the letters. We have an A squared and we have an A. The most they share is 1A. Then we look at the next letter. 1B, 3 B's. The most they share is 1B. This is going to be the greatest common factor for the letter monomial expressions. The letters are actually far easier to work with because you do them like we did the numbers on the very first example. The power just tells you how many are there. So you just need to try to figure out how many in common they have. So the left-hand side is obviously for you to figure out the number part first. And then the right-hand side is to try to figure out the answer with variables. Are we feeling okay on that? Why don't you guys take 10 minutes to try to finish this page? It looks like some of you are already working on the numbers. Try to take 10 minutes to finish this page. And I can go through the answers together with you. And certainly ask for help, work with people around you. Mikey, I can't believe I totally forgot to have you roll people. We'll have people come up and answer stuff. How's that? I see you have about 18 rolled in, ready to go. You should have yelled at me and say, hey, we haven't been calling anybody. What? What's the page you have? Oh, you're looking for the numbers up there. Got you. 74 is probably not going to be up there because the multiplication table up there is only like directly between two numbers, and one of the two numbers for 74 is going to be bigger than 10. So like, say you pick 2. If you divide it by 2 because it's even, the other number is going to be far bigger than what's on that chart.
How do I do this right here?
Okay, so the left-hand side was the number portions.
Yeah.
So we already know 30 and 56. What they have in common looks like it's just 2. Now you're going to look at the letter portions. You've got a squared and you have a. How many do they have in common? 1. They each, instead of in common, how many do they share? Might be the easier one. Like this has 2 of them, this has 1 of them. So they each have at least 1. And then you do that for the next letter. 1B, 3 B's, 1. This would be the answer.
Okay.
That's kind of how you're doing it. Maybe I should give people some notice ahead of time. Mikey, who's going to do the factor tree for 74 and 27? George, whenever you get done with that, you can come up and put the factor trees for 74 and 27. How about the next number?
10.
Oh, Kaya. The problem to the right of that, I'll have you do once George gets the number portion done. So 74 x5 and 27 x3.
Wait, no, it's a concept. So
37 isn't quite right. But it is. Oh, is it supposed to be 3 and 7?
no, it's supposed to be. Wait,
You're looking for what they have in common.
should I divide that? X5.
No,
This one has 2 and this one.
we're doing it up on the board right now, you know. Just try. Okay, next 2 people. 6. Charlie. So you are going to be charged of 3, 12, and 15. 3 numbers. And the last person?
32.
That's you. The bottom right. It's not for a little bit, though. Say what? Yep. Okay, George. Yes. 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 You can't. 37 is actually prime. Even though it's kind of a bigger number, it doesn't have anything goes into it. So now we ran into a weird situation. Oh, no, go ahead. We kind of ran into a weird situation on this problem, all right? They have nothing in common. So the greatest common factor is just going to be 1. Because the only thing that multiplies into both numbers is 1. I wasn't trying to trick you and make you think, you did it wrong or anything. Sometimes that will happen, that the two numbers don't have anything in common that goes into them. So your job basically is only to figure out what letters do they have in common. And how many of them, I guess I should say. So X is the correct letter they have in common. What's the smallest number they both have?
3.
So then that would be the greatest common factor. Perfect. Thank you. Now I know 3, 12, and 15 do have numbers in common. And 3 is pretty easy to do factor tree on because you're just going to circle it right away. You can write it off on this next to it if you want. You don't have to try to cram it all in. Yeah, you can just, there you go. Okay, so our goal is to figure out, is there any numbers that they all have in common? 3, and just one of them? Correct? So 3 is the greatest common factor. Nice job. Okay. Oh, yeah, and you already did the letter part. Yep. And then don't forget to put the 3 in the front of the letters. So when you're looking at those, you had a 3, a 12, and a 15. And that's what Charlie just figured out, is that they all have 3 in common. So 3 would go in front of the letters. Correct. That's it. Were you trying to write it separate or something? Oh, yeah, that's it. So that's the whole answer. 3fg cubed h squared. I think, no, the third one only has a single f. Are we feeling okay about this probably? Seems like a lot of you did pretty good on it. Anybody want me to answer a question on these? Okay, we're going to go to the next topic, which is factoring it out. Oh, my bad. Right here. I guess it's the third page. Do you feel ready to try these? Or would you prefer time to work on the first type still? I'm okay with either. If the first type felt really easy to you, we can just move on. If they don't feel really easy, we should probably practice them a little more. Thanks for all the feedback. You guys are great as usual. Should I just directly ask you if we should do that page of problems or not? Or is that just asking in a bad way? Should we do 0 to 5? But I kind of need everybody's answer so we know if we should do the problems or not. How well do you feel like you know that first topic that we just finished? Not good? Good. Okay? I feel like we can move on. I mean, no. Okay. I mean, these are a little bit bigger, so I guess it's a little bit more challenging. Why don't we just do the top two sets? See if you can do it with a little bit bigger numbers, more stuff. It's the same idea, just bigger numbers, more stuff. So you're going to make a factor tree for 30, 56, 20, and then look for common letters on the right-hand side. You basically deal with the numbers and letters in a separate manner, and that's why these problems are set up the way they are. Just try the top two. And I'll put the answers up here in a second, unless somebody wants to put their answer up there. What? Right there. I was going to, but I'm wondering if I should save that till tomorrow. Yeah. Yeah. I'm thinking because of time, we'll probably wait to do the next topic until tomorrow. Plus, we just took our test. I'm okay we don't necessarily need to push it really hard to get far. Our next test isn't planned until like March 1st or so. So I don't need to push through anything. I'd rather you get these than go through.
Is that what you guys got for the top one?
Did it go pretty quick? Getting quicker, I should say. What you'll find starts to happen is if you do enough of these, you kind of start figuring out what numbers are going to have in common without making the trees. And it's different for everybody when that happens. Some of you might need to do like 500 of these, and then you'll start figuring out in your head. Others of you might already be doing that in your head. You're not going to need to show your work on greatest common factor. So I'll say that ahead of time. You are welcome to show all the work you want. But I know that some people are better at doing it in their head. Some people need to write it out. So I'm okay whichever way you like to do. I'm just letting you know that this actually isn't going to be a topic you have to show work. Yeah.
How do you know when to put in what power is like the greatest common thing for that?
On the right-hand side?
Yeah.
So I just start looking at each letter individually. So then I see X4, X2, and then X1. And then I'm just trying to figure out what's the smallest number they all have in common. And so since the one on the right only has one X, the ones on the left already have at least one. One is what they have in common. if for some reason the third one said x2, then x2 would have been the smallest number they have in common. So you're just looking for the smallest they all have. If a letter was missing, so like say the third one didn't have an x wouldn't be in common at all, and it wouldn't be in the answer. Okay, how about second one? Did you guys already finish second one? No, okay, go for it. And in fact, you know what? I think, because we've got about 15-ish minutes left, I think we'll just make this, do the last two problems for today. And I will be putting up the answers in like 10 minutes or so. See if you can get the last two. I'll help whoever wants help with it. And then we will just kind of end today on that.